Distributech 2023, one of the sponsors of these interviews, and these are interviews with thought leaders from around North America and the globe. Our sponsors are H2 Scan. H2 Scan is the leading sensor manufacturer for hydrogen sensing in a lot of different applications, in transformers, in battery room safety, in processes in safety, in industrial, and in the future hydrogen economy. So I want to thank our sponsors, and I want to thank all of our guests, and I hope you enjoy this interview. My next guest is Terence Carmichael, but I know him as Terry. He is the Senior Vice President of Operations for Camlin. Camlin is a company out of Ireland, and he's going to talk a little bit about it. But thank you for joining me, Terry.
Pleasure.
All right, and for your mother, Terence, you did name him right. First thing I want to do is talk about how you got in the industry and why, and a little bit about your role at Camlin.
Sure. I started off with studying electronic engineering, and how I got introduced to Camlin was through the previous company that was owned by the Cunningham family, Kelman. And actually one of my very best friends growing up was currently working in Kelman, and suggested, I might enjoy it also. So when I went for the interview, I went in thinking a job in Lisburn, Northern Ireland, not far from home. When I left the interview, I was moving to Chicago.
And I know the family didn't like that. Some of the family.
Well, I came for a year in 2007, and it's been a very long year.
So you've been in the Chicago area since then?
Yep. Chicago's been the base. I've done extensive travel throughout North America. I think last count every state except Alaska. So I've still got to get to Alaska at some point.
All right, get to Alaska as soon as you can. I want to talk about, because you see a lot of the industry, and we're going to first of all focus on kind of where we are today, the current problems that the industry is facing. What do you think's happening in the industry? And I say industry, I'm talking about the utility industry.
Right. I think so. The big ones that everyone is probably aware of, the introduction of renewables, whether that be large-scale renewables or rooftop solar, and how that's going to affect a grid that was designed and built, many years ago. There's various challenges around that, but high-level topic, that's I think one of the biggest challenges that utilities are facing.
Okay. When you say that, because it is an issue, we used to have a step-down grid. You created power and you stepped it down out into the home, into the plug, into the industry. Now we have a step-everywhere grid. Distributed energy resources, wind, solar, whether that be utility scale or consumer scale, is just changing everything, creating power quality issues in the marketplace, a lot of different issues. We've interviewed people that address part of the issues, but as you look at one of the other major things is asset management. People are having to manage, let's talk about transformers for instance, people are having to manage their installed base longer and better because the supply chain has gotten, the lead time for some of these are out 3.5 years. They've got an aging system, you've got a demand curve for more electricity that's needed. Theirs are combining to make the creative, what do they call that, the perfect storm. And as a result of that, managing current assets and managing new assets differently is important. One of the ways to do that is monitoring, and that's Camlin's specialty, right?
Well, so I suppose Camlin would have described ourselves as a monitoring company 5 years ago, 10 years ago.
That's what I was referring to. You're saying it's changed now?
So we're looking at more, not the monitor, the physical IED itself. We're looking at more how you can benefit from data. So we still very much at our core look to innovate on the sensing side, okay? But what we're looking to try and understand working with utilities is how for them best to exploit the value of monitoring. If you look specifically at the transformer, so you mentioned lead times of transformers, which has gone up 3 years. Specialized transformers could be longer. The operation of transformers itself is becoming different. You mentioned the demand curve for electricity you've got, and really what it's introducing is uncertainty. Okay, so the way utilities have managed transformers and other assets for years is based on history, learning of how those transformers have operated. Now they're being asked to operate differently today. And so a lot of that learning and historical knowledge from utilities about how to manage that asset going into the future needs to change. We fully believe that there is the ability to monitor, measure, and through the use of techniques, whether they be machine learning, coupled with knowledge on the asset, okay, and that's a key thing, that utilities will be able to develop asset management plans going forward to your point, get extra life out of assets, maximize the utilization of the asset.
Or operate differently. If you know you got a transformer that's not maybe in end of life distress, but is beginning to show signs of it, you may not want to over-operate. You may not want to overload that transformer as much as you normally do and share that load. That's a lot of what monitoring, the data from monitoring can do for you. That's another thing. So an online monitor creates a lot of data. That data comes somewhere. And that comes somewhere to people to be able to either look at and manage, or monitor the information itself through machine learning, and sometimes AI. People tell me it's AI, and I say it's not AI yet, it's machine learning, right. I'm glad you said that. Yeah. But it's being able to take that machine learning and very quickly tell the operator what to do, because that's really what they need. I mean, we need to be able to help the operator make a quick decision about what to do, right?
You're 100% correct. So as we see the disconnect in the conversations around machine learning and how it can be beneficial, we're very, very careful with our usage of the term machine learning. We're also very careful not to purport that machine learning will be a silver bullet and will fix all your ails, answer all your problems. But the disconnect is that machine learning is good at pattern recognition. It's good at saying this thing is different than it should be, all other things being equal, right?
It's like that picture that says which one of these things is not
not like the other. Yes. So where we're focusing our time and energy is on that key next step. It's that prescriptive action.
Ooh, I like that. Okay.
So machine learning, a useful tool, but by itself can cause you more problems than answers, okay? Because a lot of things are different. Which one do you focus on? What do you do to change its state or get it back to a safe operating state, so to speak? So what we're focused on with several of our utility partners that they're doing monitoring, they've got data, is okay, taking that data and making sense of that data to tell us, for example, you should go and perform test A on this transformer or test B. To your point about managing load, there are some some issues with transformers that can be mitigated through reduction in load. Okay, so what we hope to be able to help the utilities provide is reliable power to their customers at a reasonable cost, whilst managing their assets accordingly. Okay, so it's maintain the reliability of supply without overexerting some assets and underexerting others.
Resiliency has become big because of the storms and fires in California. How can data management, machine learning, getting the right data, how can it help with resiliency, bringing a grid back up after it's been shut down by one of these unnatural or natural events?
Right. So if we look at the term resiliency, there's, I suppose from my point of view, there's two sides to it. There's what can we do to prevent one of these storms or external events damaging the equipment to begin with, okay? And then there's we can do that up to a maximum point. But then what can we do to make sure we get our customers back online as quickly as possible after such an event? Monitoring of the grid is essential. It's essential to understand at what nodes in the grid that are critical for you to get to first. It's and it's not just data from transformers we're talking about here. It's data from every data point exploitable on the grid is going to be extremely useful in not only getting customers back on, but getting them on faster.
Sounds like Camlin is moving away from a product solution to a solution. Would that be a safe?
Very much so. I think we see our position and our value add is helping utilities manage their risk. Okay, and that comes from a combination of the product, the sensor, but then also a deep knowledge of the asset itself. And then thirdly, what we're adding to that mix is this sort of data science aspect.
Yeah.
So what we've sort of observed in the industry over the past several years is the data science is being done without the expertise on the asset, and then also with little to no knowledge of the physical sensor itself. So we've positioned ourselves to chain all of that together, and to know that if one arm is moving within that chain, it's moving in conjunction with the other arms.
Oh, that's excellent. Because one of my biggest challenges for the industry, I think, is a lack of integration between different solutions. You get one supplier here, one supplier there, but being able to, at least your solution, integrate it. Can you take information from other solutions into your?
Absolutely. So core to the development of this layer of analytics is that it must be agnostic to the sensor.
Yeah.
Okay, so that if a utility is using the analytics, they're not beholden to whether it be Camlin or anyone else in terms of the development of a sensor. So this analytics can live and evolve as sensors get better and smarter and
the predictive part of what you do is going to be brilliant, because I want to go to another problem area, which is labor shortages. Everybody's suffering them, particularly the utility industry, because they've been so staid for so long, and people were not going into it. You went into electronics, you said. Most people then went off into doing electronics. They didn't go to utility work. But today there seems to be a move that we have something unique in the fact that we are changing the world. We're electrifying the world. We're decarbonizing the world. If that doesn't excite a young person to come to work in the industry, then I don't think anything will. Because we pay well in the industry, we have longevity in the industry, but now we have a purpose, electrifying the world. I think that's, and what you all are doing is part of that. As you connect what you're talking about, I see a labor saving part for the utility, right? If there's a way to help them do what they do without having more people do it, for instance, talk to me about that, because it sounds like there's, by smashing those, I'm not going to say this poorly, but smashing those three together and giving people solutions, they don't have to have a whole bunch of engineers that are taking each component and doing it themselves. Is that a fair statement?
Yeah, absolutely. So if you look at the state of, and we'll stick on transformers for a second, if you look at the state of monitoring 10, 15 years ago, and still to a large extent in a lot of areas today, if you have the asset monitored and communication infrastructure to bring that data back. So a monitor gives you an alarm. It tells you something has changed. Now there are some diagnostic techniques, for example, with DGA that allow you to kind of understand what has caused the gas increase to raise the alarm. But what an asset manager will then do is he will have to go and grab several other data points. What was happening? How was the transformer being operated at this point where this gas was created? On a very high level, on the face of it, we want to reduce or eliminate that time, because we want to already have all of the other data points, so that if an alarm's created based on an event, that is correlated to how the asset was being operated at the time of event, even leading up to the event. And so the asset manager is spending more time making decisions and actioning decisions than he is data collecting and trying to assimilate different aspects in order to make a decision, if that makes sense. So directly impacts labor, 100%. And then if you take it to the next step, we have a prescribed action for an asset based on this analytics. We know what we're going to do, we know why we're going to do it, and we know what we expect. So you're not sending, to a large part, you're not sending people to go and test assets to figure out if they have to do something else. Now, this is all sort of a staged process. You're not going to be able to just turn around tomorrow, flick a light switch and say, okay, we don't need to test assets anymore. But the end goal has to be toward that, less testing for the sake of testing and more actioning and working on the assets.
So one person can do more. That solves the labor problem. You don't need three to do the job of one. The machine and the person are kind of working together. Again, you don't need more people doing it. And I try to avoid needing data scientists because all of the big companies are hiring them away,
Right.
I think it was the National Grid in 2020, if I'm not mistaken, they hired more data scientists than they did electrical engineers. That's very telling.
I wasn't aware of that statistic, but it's...
Yeah, that was from a National Grid person that shared that with me, and I was astounded by it. Anyway, last but not least, looking at the future, 10 years out, are we just expanding on the same problems, or is there something on the horizon that we really haven't thought about that is going to be the next storm for the industry?
I think it's difficult to say. We've got a huge challenge in front of us today. In answering that challenge, will we then be putting ourselves in a position where we're unintended consequences for other challenges? I mean, if we look at the decarbonization of the network and then the growing number of weather events and climate events, if we answer those challenges, then I don't know that I see, anything as big as those. Now, you're going to see this demand curve change as we start to introduce more electric vehicles. These challenges are not easy to answer. Where we're focused right now is regardless of the grid in 10 years, one thing's for certain: you still will need transformers. You still will need the backbone of the transmission network. Utilities will always be asset-heavy companies. And with asset-heavy companies comes risk, okay? And it's managing the risk of those assets. Other regulatory challenges and different things, if you look globally, areas within Europe, for example, might have different demands on their net zero targets than the United States. But it appears certainly to us, now we've got offices all over the globe, and it appears to us that everyone is focusing on this particular challenge of net zero right now.
And the one thing that one of our guests talked about, which is true, we cannot forecast geopolitical problems. The war in the Ukraine is a perfect example of the impact that's having on Europe. So it happens. Some politician makes a dumb decision, and suddenly you've got a geopolitical turmoil. Like a lot of companies are moving their supply chain out of China. So not only do we have supply chain issues, now we're trying to move it. We're trying to bring it back to Europe. We're trying to bring it back to the Americas, whether that's South America, North America. But there's certainly an issue there. But I love the idea that the challenges we have right now, if we solve them and don't worry about 10 years down the road, we'll be able to deal with whatever comes down the road.
You would, no one could ever have predicted COVID, okay? So there's always this risk of a huge global event. But if we focus, focus sternly on the challenges that we have now, I believe that the learning that we'll accomplish in solving those challenges will much better equip us to answer future challenges. You mentioned National Grid hired a large number of data scientists. As those data scientists become familiar with the electric grid and the utility grid, they'll start to be able to introduce efficiencies that maybe we haven't even thought of yet in the grid. It's interesting, the supply chain. So one of our company, as part of our sort of global strategy, is a significant investment in North America. So we are going to start assembling, building our products here. We're investing in people, we're investing in infrastructure, and that's in part to answer some of those supply chain issues, to ensure that we have the ability to execute for our customers and partners and do it quickly, do it first time, every time.
No, that's excellent. Where are you setting up your manufacturing?
It's going to be just outside of Atlanta.
Just outside of Atlanta, where I live. How far just out? Because I live just outside of Atlanta.
Well, do you want me to tell you how far in miles or how long in Atlanta traffic?
Trust me, if you tell me miles, I can tell you traffic.
It's up towards Peachtree Corners.
Oh, okay. I used to live somewhat in that area, but oh my gosh, you couldn't pick the more congested area to move into anyway. No, that's brilliant. I appreciate that you're bringing that manufacturing here. That means a lot. But anyway, our guest has been Terry Carmichael. Terry, it's always a pleasure to talk with you. Always a pleasure to talk about Camlin. So thank you very much.
Thank you very much, Alan.
Yep. This has been an APC Technologies production, and we thank you for joining us. Our sponsors have been H2 Scan and Distributech. And of course, the communities of APC Technologies, which is Transform Technology, Power Systems Technology, Green Energy Technology, and Women in Power Systems. So thank you.